Okay, section 3.6 is using parallel and perpendicular lines. So we're going to look at two different theorems. Theorem 3.11 says if two lines are parallel to the same line, then they are parallel to each other. So if Q is parallel to R and R is parallel to S, since they are both parallel to R, then we know that Q is parallel to S. So we can say that Q is parallel to S. And then theorem 3.12 says in a plane, if two lines are perpendicular to the same line, so for example, if M is perpendicular to line P and N is perpendicular to line P, then they have to be parallel to each other. So we know that M is parallel to N because they're both perpendicular to the same line P. So this says using the given information, state the theorem that you can use to conclude that R is parallel to S. Well, they tell me that R is parallel to T, and we know that T is parallel to S. So I can conclude, okay, since they're both parallel to T, I can conclude that R is parallel to S. So I know R is parallel to S because they're both parallel to line T. So R is parallel to S. And that is just repeating the same theorem 3.11 that we just looked at. If two lines are parallel to the same line, then they are parallel to each other. And the next one says that if R is perpendicular to T, which that's marked here, and if T is perpendicular to S, then we can conclude that R is parallel to S by theorem 3.12. So again, in a plane, if two lines are perpendicular to the same line, so they were both perpendicular to line T, then we know that they are parallel to each other. So R is parallel to line S. So how would you show that C is parallel to D? Well, in 3.5, we looked at something called the corresponding angles converse. And if we can show that these corresponding angles here are congruent, then we can confirm that C is parallel to line D. So this is by the corresponding angles converse that we learned in section 3.5. And then you have to make sure that you have the word converse in there because that's what tells us when the corresponding angles are congruent. That's what tells us that the lines are parallel. So here we have two angles on the outside of lines C and D. So those are exterior angles and they're on opposite sides of the transversal. So these are alternate exterior angles. And because they're congruent, we can say by the alternate exterior angles converse that line C is parallel to line D. The converse is what tells us that line C is parallel to line D, and that's what we were trying to show. Here, these two angles are on the interior or the inside of line C and D, and they're on opposite or alternate sides of the transversal. So these are alternate interior angles, and since they're congruent, by the converse, we can say that we can show that line C is parallel to line D, which is what we were trying to show. And last but not least, these are on the same side of my transversal N, and they're on the interior, the inside of line C and D. So these are considered same side interior angles, and we want to check, do they add up to 180 degrees? And they do. And since they add up to 180, they're supplementary, and since my same side interior angles are supplementary, by their converse, we can say that line C is parallel to line D. So this is by the same side interior angles converse that we can show line C is parallel to line D. If they didn't add up to 180, then this would not be the case. We learned in section 3.2 that if one angle is 90 degrees, then all four angles are 90 degrees. Same thing down here. Since one of them is 90, these all four are 90 degrees. So how can you show? We can actually use any theorem here. We have these corresponding angles, these corresponding angles, these corresponding angles, or these corresponding angles. So we could use the corresponding angles converse to show that they're parallel. Or we have alternate interior, or we have alternate exterior, or we have same side interior that add up to 180 and same side interior that add up to 180. So it's really up to you. You could use any of the converses. Okay, it's important that you have the converse because that's what tells us that line C is parallel to line D. So find the value of x so that G is parallel to line H. So if one angle is 90, then we know all four of these angles are 90. So I'm going to look at corresponding angles. The 7x plus 13 is in the top right corner, so my other top right corner is 90 degrees. So we can say that 7x plus 13 equals 90 degrees. So I'm going to subtract 13 from both sides, and we get 7x equals 77. Divide both sides by 7, and we get x equals 11. Now you also could have talked about alternate exterior angles. Oops. So you could have talked about alternate exterior angles, so not that one. So that would have been this angle and our 7x plus 13 angle. So by alternate exterior angle theorem, we can say that 7x plus 13 is also equal to 90. A couple different ways you could do this one. So again, if one is 90, then they're all four 90. So now we know if you look at this 15x and this 90 degrees, those are corresponding angles. So we can set those equal. Because corresponding angles, if they're equal, then we can show that G is parallel to H. Divide both sides by 15, and we get x equals 6. So if x is 6, that means that this angle is 90 degrees, and since these corresponding angles would be congruent, that would show that line G is parallel to line H. All right, here we have same side, because they're on the same side of the transversal, they're both above the transversal, and they're on the inside, the interior of G and H. So we know that same side interior angles add up to 180 degrees. And if they do, then we can show that the lines are parallel. So if we set them equal, combine your like terms, that's 17x, subtract 10, and we get 17x equals 170. Divide both sides by 17, and we get x equals 10. So if x equals 10, then both those angles are going to add up to 180, which is going to show by the same side interior angles being congruent, it's going to show that line G is parallel to line H.